Good morning to one and all present here. I am Ramya Devi, working as Assistant Professor in SNS College of Engineering. Today I am going to share a small article regarding RAID. The video covers introduction to RAID and its levels, and then basically RAID. RAID is a redundant array of independent disks, is a way of storing the same data in different places on multiple hard disks or solid state drives to protect data in the case of a drive failure. There are different RAID levels, however, and not all have the goal of providing redundancy. RAID works by placing data on multiple disks and allowing input-output operations to overlap in a balanced way, improving performance. Because using multiple disks increases the mean time between storing data, redundantly also increases the fault tolerance. And there are 6 levels of RAIDs. So the RAID 0. RAID 0 is a level of RAID that provides improved performance by stripping data across multiple disks. However, it offers no redundancy, meaning that if one disk fails, all data is lost. RAID 0 is commonly used in situations where performance is more important than data protection, such as in video editing or gaming systems. RAID 1 is a level of RAID that provides redundancy by mirroring data across multiple disks. This means that if one disk fails, the data can still be accessed from the other disk. RAID 1 is commonly used in situations where data protection is more important than performance, such as in financial or medical systems. Next is RAID 2. RAID 2 is a level of RAID that uses bit-level stripping with dedicated Hamming code parity. RAID 2 provides high data transfer rates and fault tolerance, but it requires a large number of disks and is not commonly used in modern systems. One advantage of RAID 2 is its ability to detect and correct errors at the bit level. This makes it useful in applications where data integrity is critical, such as scientific military systems. RAID 3 is a level of RAID that uses byte-level stripping with dedicated parity. A single disk is dedicated to storing parity information, which can be used to reconstruct lost data in the event of a disk failure. One advantage of RAID 3 is its ability to provide high data transfer rates for larger files, making it useful in applications such as video editing or multimedia production. RAID 4 is a level of RAID that uses block-level stripping with a dedicated parity disk. This level uses large strips, which means a user can read records from any single drive. Overlapped I/O can then be used for read operations. Because all write operations are required to update the parity drive, no I/O overlapping is possible. Overall, RAID 4 is a reliable and cost-effective option for systems that require high speeds and moderate write speeds. RAID 5 is a level of RAID that provides both performance and redundancy by stripping data across multiple disks and using parity information to recover data in case of a disk failure. RAID 5 requires at least 3 disks and can tolerate the loss of one disk. It is commonly used in situations where a balance between performance and data protection is needed, such as file servers or email systems. RAID 6 is a level of RAID that provides even greater redundancy than RAID 5 by using 2 sets of parity information to recover data in case of 2 disk failures. RAID 6 requires at least 4 disks and can tolerate the loss of 2 disks. It is commonly used in situations where high data protection is needed, such as in online backup or archival systems. RAID is a powerful technology that can provide both performance and data protection benefits. However, choosing the right level of RAID depends on the specific needs of the system and the trade-offs between performance capacity and data protection. By understanding the different levels of RAID and their characteristics, it is possible to make informed decisions about how to implement RAID in a DBMS. Thank you.